An immense cosmic boulder rockets in from deep space on a direct collision course with Earth. When it hits, it unleashes a global catastrophe. This is not science fiction. It happened 65 million years ago. And much of life on Earth, including the dinosaurs, died. Today, many scientists believe that this is not a one-time event, that what wiped out the dinosaurs could happen again, and we could be next.
Will another impact occur? You bet. It's going to happen again. The Earth is sitting out there with a bullseye on it.
What are these mysterious invaders? Where do they come from? And if one threatens the Earth again, will we be able to stop it in time? We think of comets as some of the heaven's more spectacular pieces of eye candy, and most are benign, orbiting harmlessly around the sun. But some will inevitably collide with another body, like Earth. At speeds of 25,000 miles an hour, even a small cosmic raider can wreak enormous havoc. But a larger object, over a mile or more in diameter, could cause devastation on a global scale.
An impact by a comet will kill so many people and can produce such long-term changes in the environment that it can be a complete catastrophe for all of humanity.
Scientists now believe a single blast from space helped wipe out the dinosaurs 65 million years ago. A comet, or asteroid, about 6 miles across, slammed into Mexico's Yucatan Peninsula. It dug a crater nearly 50 miles wide and 20 miles deep in less than a second, and unleashed an explosion more powerful than all the world's nuclear weapons combined. The force of the shockwaves triggered earthquakes worldwide and sent tsunamis surging across the oceans. A mammoth dirt cloud erupted miles into the sky, engulfing the globe and blocking out the sun for years. The dinosaurs slowly perished, and they were not alone. More than half of the Earth's species were also wiped out. In our solar system, there are two kinds of cosmic bullets capable of devastation on a planetary scale: asteroids and comets. Asteroids are essentially tiny planets, dense boulders of rock and metal left over from the formation of our solar system 4.6 billion years ago. Most are bunched between Mars and Jupiter in an orbit called the asteroid belt. Comets, on the other hand, are far more mysterious. Though also formed at the birth of our solar system, they are made up of rock and ice. Many, like Halley's Comet, orbit the sun in predictable paths on predictable schedules. But there are countless others we know nothing about. They come hurtling out of the ether at unimaginable speeds of up to 100,000 miles per hour. For scientists peering into space, they look like lumps of charcoal on a black canvas, invisible until they are practically upon us. Only near the sun do comets become easier to detect. These icy bodies shed gas and dust as the sun warms them. When light hits the debris, they blaze into view and can be seen for millions of miles. But by that time, if one is headed for us, it may be too late to do anything to stop it. To date, more than 1,000 comets have been identified. Every year, we spot perhaps 100 comets we've never seen before entering the inner solar system. Each new arrival increases the odds that one will eventually strike the Earth.
The Earth is in a cosmic shooting gallery. We get hit by pieces of comets and asteroids of all sizes, and the big ones certainly pose a very real threat.
It's only a matter of time before the comet is in the same place as the Earth.
Giant pockmarks all over our planet testify to past assaults. And these collisions may be more frequent than we like to think. The latest big one happened a little more than a century ago. In 1908, a massive explosion rocked Tunguska in Russia's remote region of Siberia. Eyewitnesses described a flying star with a fiery tail. The sky opened and a fire brighter than the sun poured out. Whether an asteroid or a comet, it collided with the Earth's dense atmosphere at such a high rate of speed, the friction caused it to explode in mid-air.
It blew up 5 miles above the surface of the Earth, creating this huge explosion and lit up the atmosphere for days. You could actually read in Europe at night.
The Tunguska blast, as we now call it, was bigger and more powerful than the eruption of Mount St. Helens. It left no telltale crater, but it did flatten a forest of millions of trees over hundreds of square miles, an area bigger than that of Washington, D.C.
If that would have happened over a metropolitan area, it would have just wiped out the population for thousands of square kilometers around the impact site.
To astronomers, Tunguska was a near miss, a relatively minor impact. But a major impact from a comet would have devastating effects. Imagine the following scenario. Scientists have spotted a 2-mile-wide comet on a collision course with Earth. It's too late to stop it.
The first thing you'll know is when the sky lights up and the ground shakes.
Brilliant meteors streak across the sky as the giant comet's debris strikes the Earth's atmosphere. Forests catch fire, ignited by the superheated air. When the comet hits, the blast kicks up millions of tons of fiery rock and dirt. The airborne debris blankets the planet and blocks out the sun. Day turns to permanent night, bringing freezing temperatures and year-round winter. It takes more than a year for the dust to settle and sunlight to filter through the clouds. When it does, the Earth starts to warm, quickly. Elevated levels of gases created by the fires turn the planet into a sweltering greenhouse. Millions of species of living things that survived the earlier cold cannot take the heat. They die. It takes thousands of years for life on Earth to recover. How great are the odds a comet will strike the Earth?
Will another impact occur? You bet. It's going to happen again. The Earth is sitting out there with a bullseye on it.
The chances of a major impact in our lifetimes may be slim, perhaps on the order of 1 in 100,000. But astronomers the world over are working fervently to understand these strangers in our midst, struggling to learn what comets are and where they come from. Mankind's ultimate survival may depend on our ability to stop one before it strikes. Donald Yeomans studied comets for NASA's Jet Propulsion Laboratory.
They're so big that they've got a lot of mass, and it's mass and velocity that's important when they hit.
If we could track comets in advance and plot their orbits, we'd likely have many years of warning if the orbits veered toward us. It may seem like a tall order to scan the vast sea of space for that one pinprick that could spell disaster. But that's exactly what astronomers are doing. In 1992, the US government launched an aggressive program to analyze the threat comets and asteroids pose to Earth. It's called the Space Guard Survey. Today, scientists all over the world are involved in the painstaking process. They point their telescopes at a single region of the sky and take periodic snapshots. Then they line up the images, looking for anything that moves from frame to frame.
We are looking first for the larger asteroids and comets, the ones a mile or so in diameter, and eventually we'll extend it to the smaller ones.
Scientists have discovered nearly 4,000 comets in our solar system, with roughly 40 new ones in 2016. New comets are being discovered every year. We may never be able to locate every threat. There could be millions of comets and asteroids that measure 300 feet or so, the length of a sports field. Still, telescopes are a first line of defense against what could be a major disaster for our planet.
If you don't look, you won't know anything's coming. We would be taken by surprise just as much as the dinosaurs. If you do carry out a survey, then you hope that you can have warning. But it's one or the other. Either you have years or decades of warning, or you're taken completely by surprise. There's nothing in between.
There's three things that are important. You have to find them early, you have to find them early, and you have to find them early.
Suppose we do detect a comet headed for Earth. Then what can we do? Scientists have just started to come up with solutions. One of the leading ideas? Smash a rocket into it to slow it or knock it off course. That's harder than it may seem. In 2005, scientists were ready to test their theories about how a comet would react when it was hit by crashing a rocket into one. It was called Deep Impact. It began here at NASA's Vertical Gun Range in Mountain View, California, where it was the job of Dr. Pete Schultz and his team to figure out what the comet would do when it was hit.
This particular instrument allows us to fire a small sphere, about a quarter inch, at speeds that are maybe 6 or 7 times the speed of a rifle bullet. This whole assembly rotates up to an elevation where the gun is basically 3 stories high. This allows us to send the projectile through different openings in the chamber so that we can impact a flat surface at different angles.
Scientists believe comets vary in their makeup, so Schultz and his team built several different models, then hit each with a shot from their ultra-high-speed gun.
The first scenario is what happens if we impact into something that looks like lunar dust. The second one is what happens if we impact into fluff. And the third one is what happens if we impact into a fluff covered with an organic layer. As we go down and look at the evolution of this crater, we find at the very end, after it's finished, we can still see the crater here. But in these 2 cases, when we're using fluff, we can't see the crater. It's completely masked.
The fluff completely absorbed the projectile, a frustrating result for scientists hoping to get a look inside. And there was another possibility Schultz had to consider. What if the entire comet is extremely fragile and porous? He searched for a substance for that simulation.
The comet may be sort of like a fluff ball. It may have been very low density. What do we do to try to simulate that? The best thing probably is a complex organic. What would that be? Cotton candy. We've got our comet made of cotton candy. Let's turn off the lights and let's get out of here.
The projectile soars right through the comet, but the force shatters it.
Oh my God! There's no more comet, that's for sure. What a mess.
But this is not good news. A shattered comet can be even more dangerous than an intact one. The pieces remain on the same course, turning one projectile into many. But what does that mean for our planet if we're in the way? In 2005, the team at NASA had completed their tests and were ready to take the plunge. They would try to drive an 820-pound impactor into a comet to find out what's inside. Deep Impact Principal Investigator, Dr. Michael Ahern.
So here we have the model of both Deep Impact spacecraft. Many people think it was only one spacecraft, but it's really two.
January 12, 2005. After 6 years of study and preparation, Deep Impact is ready for liftoff.
3, 2, 1. We have ignition and liftoff of a Delta II rocket carrying Deep Impact.
The spacecraft's destination is a 4-mile-wide comet named Tempel 1. Discovered in 1867, it's well known to astronomers. It orbits the sun every 5.5 years and has lost much of its gas and ice.
People would argue that you should preserve the comets for posterity, but doing a violent study on one that is just typical of a whole class seemed to us to be the right choice for science.
Deep Impact takes 5 months to reach Tempel 1's orbit. On July 2nd, 2005, it turns and points its cameras at the comet, 500,000 miles away. Then, it releases its impactor. If all goes well, the collision will blow a hole in Tempel 1 about 600 feet across, 5 stories deep, about the size of the Roman Colosseum. But it might destroy the comet by breaking it apart like cotton candy in the experiment. Back on Earth, hundreds of scientists hold their breath.
We lost signal and we had to stand there and wait around. So everybody was trying to be, go keep busy and not feel anxious.
But just before impact, the signal returns. The half-mile-wide comet and NASA's 820-pound craft have collided at 23,000 miles an hour. The explosion is equal to nearly 5 tons of TNT. It completely vaporizes the impactor and kicks up far more dust than anyone expects. The amount of dust is a telltale clue to the comet's makeup. Tempel 1, at least on the surface, contains far less ice than scientists expected.
This is the first data we've ever had. So in that sense, it's revolutionary.
Analysis of the dust showed molecules containing carbon, organic material. So it's plausible that comets could have brought such material to Earth early in its history. Scientists hope to learn something else from Deep Impact. Clues about how to stop a comet from colliding with Earth. Some thought Deep Impact might knock Tempel 1 into a slightly different orbit. But the comet has continued on exactly the same path as before.
It was a secondary objective of the Deep Impact mission to come up with a plan to mitigate an impact if we had to.
Did we figure out what it would take to move a comet out of an orbit that was intersecting the Earth? We didn't figure out enough.
One plan calls for detonating a nuclear warhead near the comet to nudge it onto a different path. A controversial proposal because of the unknown consequences of releasing radiation in space. Others have called for drilling into the nucleus and setting off a blast inside. But as we've seen, this has the danger of turning one deadly projectile into many. The pieces could continue on the same orbit, and like the blast from a shotgun, wreak destruction over a wider area. Some have proposed less violent, yet equally intriguing solutions. They suggest putting lasers on the moon, where the Earth's atmosphere would not deflect them. The lasers could bore into a comet and melt its icy glue. We might even hitch a spacecraft to a comet and tow it out of our way. Whatever the solution, all ideas remain on the drawing board.
If a comet is on a collision course, we may not be able to do anything.
Even if we could tell tomorrow that something is headed our way, we don't necessarily have the means right now to protect ourselves.
But one day, we might just look to the heavens and find a comet with our number on it, headed our way.